8.4 in the grade 9 academic course, midpoints and medians and triangles. The goal for today's lesson is to use properties of triangles and just to find out other stuff, everything that we can. So there's lots of properties of triangles. We're only just touching on the surface, but our goal is to learn a few properties of triangles and be able to solve some problems about triangles, which may seem like not such a big deal. But by the time you get through, we basically do properties of triangles all the way through grade. You take your very last math course in high school, calculus and vectors, or you take grade 12 physics and we're doing triangle math. So triangle math is a much bigger deal than you might think right now in grade 9 math. And as you get older, take more math courses, you'll start to realize why. So this has a lot of relevance for later on. Just trust me on that. So just remember the three main types of triangles. Acute, there's my little attempt at being witty. Young and pleasing to the eye is if you're a acute triangle, but what it means is all the angles inside are less than 90 degrees. And then obtuse means you have one angle greater than 90. And I'll leave it to you to tell me why you can never have more than one angle greater than 90. Why can it only be one, not two angles greater than 90? You think about that and tell me why. Okay? And the third type of triangle is a right triangle, right? So we talked about right triangles in the past, or maybe we haven't. Maybe we haven't, but here we are talking about right triangles. Okay, so another term that's important to us is the term bisector specifically, but then if it's a right bisector, it just means you have a line. So say I have some line segment AB, okay? A right bisector is a line that cuts it. Bisect means cut in half, okay? And then the right part just means that it's crossing at a 90 degree. Okay, so it's not coming across on an angle like this. Because theoretically, if I had a line where my mouse is following here, that would be, as long as it crossed at exactly that point, it would still cut AB in half, but it wouldn't be right. It wouldn't be right because it's not coming at a 90 degree angle. Okay, so just remember the two terms. Right means 90 degrees, and bisector means cut in half. Okay, the term median. You may have learned the term median in math before, in data management. Of course, with geometry, it means something completely different. A median for us is if you have some vertex, any vertex, and then it's going to come across to the opposite side of the triangle. If it comes across and cuts that side in half, it's called a median. So for example, you could have a line that starts here and ends, say, way over here where it's not cutting this in half. Well, that wouldn't be a median. Okay? And the midpoint, I guess, would be right here. So when we say midpoint, we just mean sort of that spot right where it's the middle of that line. So just a couple little rules that we can use to solve problems. What I'm saying here, and you'll have to draw out the triangle. So you have some triangle, ABC or ACB. MN, if MN joins at the midpoints, and what that means is this and this are the same length. Okay, so that means that M is at the midpoint. And similarly, these won't be the same length, but say I have that. And that's my way of saying that, where I have that two hashtags from here to here. CN is the same length as NB. So this is MN is breaking this line segment in half and this line segment in half. The two things that I know then, if this MN is positioned to cut it in half, that means that MN is parallel, and by parallel I can make this little sign to say parallel to AB, and it's exactly half the length. So if AB was 20 centimeters, MN would be 10 centimeters. Okay? The other rule then, and sort of everything's highlighted in here, the other rule is the height of the triangle formed by joining the midpoint of two sides. So again, this line here, if you see this here, refers to the fact that it must be joining this line segment exactly halfway up at the midpoint. So here's the midpoint. Here's the midpoint. So what we know from the last rule is that this line is exactly half as long, and so that's what this means. That says 2L. So if this is L, L could be 10 centimeters. This length would be 2L, or 20 centimeters. Now, if you look at the height of these, this here would be the height of the big triangle, right? This whole length. This height right here, just a little bit from L up, is exactly half of the full, which means that this height is the same as this length. Okay, so from here, where my mouse is right now, to up here is the height of the small triangle. It's half of the full triangle. Okay, last rule. The medians of a triangle bisect its area. So again, if I had, now you don't have a color in that, but I have this big triangle here, and I make a median starting at A, so it cuts this in half. That means that this area and this area are equal to each other. So there's 3 little rules related to triangles. We should be able to use those rules to solve some problems. We're going to skip this, okay? Counterexamples and conjectures, not really that important, and we're just going to leave it alone. Okay, so just one little example using one of the rules that we did, and then you can just do the practice problems in your assignment to see the other ones in action. So if I have ABC, so ABC, this big triangle, and we know its area is 10 centimeters, what's the area of ADB? Well, the way that you know is that this line here is a median, right? Because these two lengths are the same. And since this is a median, that means this area has got to be equal to this area. So, which means that I'm cutting it in half. So ADB has got to be half of the original, so 5 centimeters. Okay? So you go ahead and take a look at the some of the assigned problems and work through these, and just try to keep going back to the rules to see how they do. And if you have any questions, make note of it underneath and ask me in class.